Hello everyone, welcome to my presentation about our project, Research, Design and Development of Lion Rehabilitation System based on Augmented Reality and Artificial Intelligence, was researched by the author Nguyen Quoc, Nguyen Toan, and Trần, and I am Nguyen Quoc, the presenter. According to the American Stroke Association, stroke is the fifth greatest cause of mortality and leading cause of paralysis in the United States. Post-stroke patients frequently experience total or partial loss of movement, which 80% of them are hemiplegic. However, the current price of therapies is exorbitant. In the United States, the overall cost of stroke in 2008 was estimated at 65.5 billion USD. People with hemiplegia are frequently treated through a multidisciplinary rehabilitation. Currently, there are four main rehabilitation methods: traditional methods, robot, virtual reality, and augmented reality. Each method has its advantages and disadvantages, in which AR is highly appreciated, has great potential for development in the field of rehabilitation, and does not have any significant disadvantages. So to create an effective method, we have studied a rehabilitation system that combines the merits of ability to collect training parameters of robots, AR's captivating interface, and AI's intelligence called RAA. With the assistance of AI in model the user posture, recommend exercise schedule, analyze and evaluate exercise results. The rehabilitation system has become more self-sufficient and decreasing the physical therapist's presence and the medical burden. The medical idea is inspired by a rehabilitation robot, a planner robot with a hand crank and a pedal mechanism for rehabilitation. In addition, is a power assist model where the patient shows signs of fatigue. And here is the picture of mechanical system after it was designed. The electrical control system structure consists of three blocks: input, processing, and output. The input block includes an emergency button, torque sensor, encoder, camera, and feedback signal from the motor. The device collects actual physical parameters as well as control signals and sends them back to the processing block. The processing block includes a central computer and a microcontroller. Most of the signals from the input block are raw, unprocessed signals, so these signals are sent to and preliminarily processed at the microcontroller, then sent to the central computer to continue processing complex operations that require high speed and accuracy on the basis of AI. The output block includes a motor that works according to the control signals sent from the central computer through the microcontroller to support the patient in practice. Computer version is used to capture user immediate data to embed it in the virtual world. Besides, it's also an input to evaluate and correct posture of the user automatically. The immediate data is taken from the camera placed on the paralyzed side of the patient. MiniPy library is used for computer version, helping to detect important joints in the scalene system, thereby calculating the joint's angles. Then, the ANN compare the joint angles data with a stand posture, thereby providing appropriate training instruction. The training course is built on the basics of fuzzy logic with the input of the patient's health parameters through the recipient rules from the instructions of Ministry of Health and doctors. The results are obtained is training time and level of practice. The exercise interface is shown as the picture divided into three main parts. This is game view. The user will transform into a character with a first-person perspective and perform activities such as cycling or rowing. The second part is the picture of the user embedded in the game. Part 3 is the real-time user workout parameters, and here is a video about the interface.
The system's interface software is designed as a game on the Unity platform, and users logging in using the given QR code. After logging in, new users must fill out personal information as well as health data. The system will then create a core achievement based on the fuzzy algorithm using four inputs: age, FIM, arm and leg muscle strength. After that, the users choose an exercise and perform the workout. After signing in, those who have previously exercised will be asked to complete the pain assignment after 3 hours of exercise. Following that, the course of treatment will be adjusted to fit the patient's current health status. When the user is in pain, the system reduces intensity of workout and increases it when he is healthy. There are two parameters in this exercise: training time and resistance level. Games such as rowing and cycling are used to improve arm and leg muscle strength. The game will features a 3D model that simulates the workout process, as well as engine speed, torque, and engine's assist level. The movement speed of the character will be proportional to the user's workout speed. Throughout the workout, the user will be reminded to adjust the workout speed to the required speed. Additionally, owing to the image processing technologies, users will receive a notification to correct their posture while training. The system will compare the reference value to the position and angles between choices. The results display table indicates the level of exercise completion in terms of time, speed, torque, and accuracy once the exercise is completed. The system will then evaluate patient's level of rehabilitation with each workout. Users and doctors will be able to monitor and access all data collected during exercise.
Here is an overview of the system. It consists of a mechanical system with sensors and actuators, a camera for image processing, and a screen to display the interface. To get a survey opinion on the functions and performance of the system, we conducted an experiment with 50 volunteers with an age range of 31 to 65 years. Experimental participants performed arm and leg exercise on the REA in treatment room or outdoor. Then they perform a small survey of the system on the Likert scale. This is the scale used to determine respondents' opinions on a question or point of view based on their level of satisfaction. The responses are conventionally on a scale of 1 to 5, which 1 is extremely dissatisfied and 5 is extremely satisfied. The survey includes 10 questions about the RAA's design, user comfort when exercising, safety, and application capabilities. This is statistical chart of survey results. In general, we have an average score of 3.92. This is a pretty high score, with all answers nearly satisfied. That shows that the system has been well designed and manufacturer has high applied capability and effectively meets the expectation of users. The treatment course is assessed by the therapist. This process is done by sending the data of 50 volunteers on health indicators and their output scores like that to 5 therapists at the Department of Traditional Medicine of Turuk Regional General Hospital. Then, doctors use their expertise to evaluate the appropriateness of the course. Through the process of working and synthesizing, the results of the evaluation are as follows: 88% were assessed as appropriate, 10% as needing adjustment, and only 2% were judged to be unsuitable. Although the experiment scale is relatively small, it can be seen that the training process has almost met the criterion set by the Ministry of Health. However, the AI network still needs more training to reliable above 90% to be able to commercial. Through the topic, REA showed that it increases patient motivation exercise and allows them to interact with the AR environment where they can participate in sports activities even if their health does not allow them to do so in the real world. This system evaluated by patients as making them more comfortable, achieving high efficiency, and thereby reducing rehabilitation training time. Patients can perform their own low-cost rehabilitation activities at home without requiring the assistance of medical doctor. However, the exercise is still monitored by the system and notified to the doctor when necessary. This helps reduce the overload of patients and physical therapy facilities at the medical facilities. Our team also has one paper published at the ICAS conference with the name Implementation of Rehabilitation Platform based on Augmented Reality Technology, and one paper that accepted and presented at HCMUTE conference with the name Alliance Rehabilitation Training System based on Augmented Reality and Artificial Intelligence. Thank you for listening.